Hi. Okay, so today we're going to be going through Module 1, Lecture 3. So you should have already watched Modules 1, Lecture 1 and Modules 1, Lecture 2. Module 1, Lecture 1 had kind of a gentle introduction to R, just some of the values there. I strongly encourage you to go use the R program that's available on Moodle, download it and run it, and just make sure that it works and that you kind of understand what's going on. You can also, look through the lecture materials to do that. And then for lecture 2, we have some random number generation. So I also encourage you to do the same there. Okay, so we're going to get into module 1, lecture 3, which is going to be a full sort of data analysis approach. We're going to kind of read in our first real data set. We're going to jump right into it. And based on that data set, we're going to do some basic descriptive statistics. So we're still not going to be doing any tests yet, no hypothesis testing. We're just going to be doing things like, okay, let's take the mean in this subset of patients, just kind of processing the data a little bit, doing a little bit of plotting. And this is what's going to really help you for the third homework. So at the end of this module, I will go into the third homework and explain kind of what I'm looking for there. Okay, so let's go online. So online, if you go to the Module 1 resources, I need to sign in again. You go to the Module 1 resources and we go to lecture 3. So what you'll see in lecture 3 is two different data sets. One is the COVID-19 pregnancy data file and one is R code. So we're going to be looking at both of these. So I want to download each of these and I want to, save them in a file that I can use. So I'll do that on the fly right here. Okay. So let's download this file first. So this is the COVID-19 pregnancy file. I want to explain kind of what the variables we're looking at are. So here we have ID number, and you can see just kind of looking down, this data set has 1,000 patients in it. We have patient BMIs. We have patient ages. We have patient COVID history, where a 1 means that they had COVID at some point and a 0 does not mean that they had COVID. We have patient history of C-section. So this is for pregnant people. So they're pregnant and we want to look at their delivery status. So whether or not they had a C-section in their previous pregnancy. We also have whether or not they have type O blood. And then lastly, we have whether or not the baby was delivered as term delivery. So term delivery, right, is I think 37 weeks. So whether or not the baby was delivered after 37 weeks of gestation. Otherwise, they would be preterm. So the idea here of this kind of study, what we want to look at is, does having COVID in the past influence your term delivery status? Does your age influence your term delivery status? Does your BMI, do heavier people have less likely of term delivery? Does a history of C-section decrease your chance of a term delivery, and type O blood? So we're going to be looking at all of these separately. And we're not going to be doing any statistical tests here. We're just going to be looking at, okay, well, what is the percentage of babies that were born term within each of these groups, within the COVID history positive patients, within the COVID history negative patients, within type O blood, within history of C-section, within various subsets of age. That's what we're going to be looking at for this assignment. So the first thing you're going to want to do is you're going to want to save this file somewhere. So here I'm just going to pick, my desktop just as an example. Hey, look, I've got my desktop. I have it here. So I'm just going to save this on my desktop just so everybody can see how I'm doing it. Okay, I've got it in my desktop. And then what you're going to want to do is you're going to want to open this R code right here. So you see this R code. Here I have kind of all this code and we can copy it. We can go into our studio and we can paste it. So what I want to do, right, is the first thing I want to do is maybe save this file. I can save it here as, a data file. I can call it COVID pregnancy 1, something like that. This is on my desktop. You can put it wherever you want. Okay. But what we're going to do is we're going to point to it. So this is the set directory command again. If I look at my directory in the bottom, this is where that's just a weird error. Sometimes you get that error. Don't worry about it. So here I have my working directory in the bottom. I am not on the desktop at all. So if I want to figure out, hey, where is this file? What I'm going to do is I'm going to go to in my folder where my desktop is. I'm going to find this file, COVID pregnancy. I'm going to click on the properties here, and I see this is the file location. So I'm going to copy this. I'm going to walk back into here, and I'm going to reset my directory. So I'm just going to copy this here. Now, why do you have quotation marks here? The quotation marks are that's just a way of R to know, hey, look, this is a character string. This is like a character variable that is being fed in. So just like in the first lecture of this module, right, we had the students' names, Greg, Julie, Diane, all of them. Those would also be character strings. Now, I do want to point something out. If you do something like, let's say I am in, this here, and I have something that says character, and I copy paste from Word. I just want to point this out because it's a common bug. It's not the same. You see how it's not green, whereas this is green here? You need to actually input the parentheses in R itself. So see how now it's green? It just has a different character. I don't know why it won't recognize the Word one. It's just something that you'll see. So this is the file location. I actually need to flip these in the opposite direction. So I need to flip these in this direction. Oop. Here, 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 here. Okay, and then now I've got my new set directory, and I can type in get WD. This is where I am. I can look at the files here. So I could say list.files, and I can go look around. Okay, these are all sort of things that I have. I should have COVID pregnancy here. I can actually copy paste this file. So this is a nice way. I don't necessarily have to go, back to my desktop and say, oh, look, it's COVID pregnancy. I can actually, once I'm in that file location, I can use the list.files command and just put it there. So what I suggest that you do is go make a totally new folder. So for this homework, you're going to make a folder homework 1. You're going to plop that data set into there, and then you're going to go to that file. You're going to use list.files to see it, and you're going to upload it. That's going to be the first thing you want to do. So I strongly encourage you, after you watch this lecture, to immediately go to the homework and just load the data set. Just get the data set into R, and that's it. So I'll copy paste this here. And I think a good way to learn how to code is just work off the examples, right? I have an example right here. You can totally work off of it. So now we're going to read the data in with the read.csv command. It ran. This header command is a good thing to look at, because this header command, again, what it shows you is just kind of the first couple rows of the data. So the header command is basically going to show me this. But once I read the data into R, I don't really need to work with Excel anymore. So the header, you can see, it shows me that I have columns, ID, I have BMI, I have age, I have COVID history, I have a history of C-section, I have type O blood status, and I have term delivery status. If I want to index things directly, right, I can say, like data BMI. Okay, these are all my BMIs. You can see them here. I can type in mean data BMI. Okay, that's the mean. Another function that's really useful is the summarize function, which we'll see in a second. So I can say summary data BMI. Oop. See how whenever I do this $, it'll pull up what I want to summarize. So I see, okay, look, I've got the 5-number summary. You've probably seen this before. I've got the minimum. I've got the first quantile, the median, the mean, third quantile, and the max. I also might want to make a histogram and just kind of look at this. So hist command here will do the histogram. Actually, the bare bones version is just hist data BMI. And you can see here this plot that I made on the right. It doesn't have, labels that I want maybe, or X labels, so I can adjust that. And that's what it do here. So if I want to change this X label to be something else, I say X lab equals BMI, or whatever you want it to say. You could say BMI of patient. And the main title, this will plop it. So this is going to replace this title up at the top, the main command. So I think when you're starting out, the best way to do this is just make the histogram first and then start adding little bit by bit, right? So I might say, okay, main equals title. And you can see here that it changed the title. So here, this will change both the title and the bottom. You can see that here, BMI histogram, and then I had BMI of patient. Okay, some functions, right, of this. I can pass functions through from R. The summary function, super nice. We just saw that. Gives you 5-number summary. I could look at the mean of the data. I could look at the max of the data. I could look at the min of the data, right? I can come down here and type in min data BMI. I can look at the standard deviation data BMI. I can look at the variance data BMI. I could say help bar. If I don't know, what I'm doing, I can say help, min, and it'll tell me, oh, look down here, this is a maximum and minimum. Now you can also go look, obviously, like a good way to do this, and I think starting out is fine. You can come over to, and I'm totally okay with this. I think this is totally valid on homeworks. I have no problem with it. You could say, you could go to Google and you could say like how to find minimum of a vector in R, something like that. Okay, and then it'll say here, oh, we can do this with the min and the max function. You'll also see, I don't know if you're familiar with it, but stack exchange. So stack exchange, you might see some of the responses. So basically what this does is people will ask questions and then you'll get, hey, look, this is how you actually do it. So it's totally okay to do this while you're learning. And it's okay to work together again, but you cannot copy each other's exactly. And you can't copy from online, which, I mean, there shouldn't be exact answers online because, I make up my own problems. So that shouldn't be much of an issue, but totally a valid way to learn, and be patient with yourself. It's a steep curve. That's why this homework is kind of a little more on the basic side. I just want you to read it in and then mess around with the data a little bit. Some other information I might want to look at is, okay, how many patients had term delivery and how many didn't? So I can use this table function here, which again, the table function tells me all the unique values and how many times each happened. So I can see a 1, which means they had a term delivery, happened 574 times, and a 0, which is how many times they didn't have a term delivery, so preterm, before 26. I can also take the mean of this, data term delivery. This will give me the proportion. So 57.4% of patients had a term delivery. If this is coded as a 1 and a 2, sometimes you'll see data sets like that. Then you'd want to, separate this out like this. You'd want to say, okay, equals, something like that. Otherwise, it would basically give you 1 point something, right? The mean of 1s and 2s will be between 1 and 2. Another useful thing of the table function here is from the table function, I can actually table cross tabulations. So what this table function does here is it's going to create a 2x2 table that looks like this. Okay, so this is, I have COVID history in the beginning and I have data term delivery in the second. And let me run it first. So what this is saying, right, is I have, these are my COVID histories down here, 0 and 1. And these are my term delivery statuses. And I can verify that just in case you forget, right? I can say table data COVID history. And you can see, right, 107 patients had COVID historically. And if you look at this row, 61 plus 46 is 107. Okay, so what this is saying is out of these 107 patients with COVID positive, 46 had a term delivery compared to 61 who didn't. Out of the 803 patients that did not have COVID, 528 had a term delivery and 365 did not. So if I want to estimate, okay, what's the percent of mothers here that had a term delivery, I can do 46 divided by 46 plus 61 like this. That gives me 0.42. If I want to get the percent in the non-COVID history group, it would be 528 divided by 528 plus 365. So that's 59%. So you see that in the COVID history group, there is much lower, about 17% lower likelihood of having a term delivery. Now, another thing you might want to use, you can actually do this directly using this command. I'll show you how to do it. It's called prop.table. So if you pass prop.table around this and you call 1 like this, you can actually look at the help command first, prop.table. I've only been using this function recently. It's just it's easier. So it returns the fractions as a marginal table. So you say which margin you want. So 1 would be rows, 2 would be columns. It tells you here, 1 indicates rows, 2 indicates columns. So I want to take the percentages in each row, which is what we just did. That's how this works. And you can see, right, I get the same numbers. So I get 59% in the no COVID group, and I get 43% about in the COVID group. So there's quite a big difference, right, in term delivery rates based on COVID history. Well, let's keep moving down. Maybe I want to look at things like, okay, I can also do a subsetting command. So what this does here, just to explain the syntax. So remember, right, if I want to index the first entry of term delivery, I can say data term delivery of 1. If I want to get the second term delivery status of 2. If I want the first 10, I can do this sequence right here. Now, what this is going to do here is this is turning this into a logical statement. This is saying, hey, COVID history is equal 1, and it creates a vectors of trues and falses. So in R, whenever you plug in this vector of trues and falses into that bracket, the index COVID history, what that's going to do is it's going to pull out all of the term delivery statuses for only COVID history equals 1, because that's what I have here. And you can see that if I look at this, it should be about 100 and it's 107 values here. Now, if I want to get the proportion of patients here that did have COVID, I can simply just take the mean of this vector. So I take the mean, I get 42%. I can also look at this, I get 59%. I can do other things with this kind of thing, right? So like maybe I'm not interested in COVID history. Maybe I'm more interested in how the BMIs change in these two groups. I can do the same kind of thing, right? So all I got to do is change this index. See how I have term delivery here? I just change it to BMI. So now I'm indexing the BMIs of the patients that had COVID. And you can see them all right here. It's still 107, right? So we know, right, there's 107, and I can just check that again, data COVID history. I have 107 yeses and 893 no's. So I can plot a histogram of these if I want. So what I'm saying is, hey, look, I want a histogram of this. My title here is BMI for COVID history patients. My X label is BMI. And I can look at that right here. So that's what this plot looks like. I can do the same thing here, and that's what this plot looks like. Now, I want to point out something. Notice how this one has only maybe 5 boxes, and this one has a bunch of boxes. Well, one thing you can do to control that is you can go to help and hist. And if you look at the histogram documentation on the right, you'll see that one of the arguments is breaks. And so breaks, what it does is tells R how many boxes do we want here. So let's just add that in. I can come over here and I can say, you know, breaks equals 50, for example. Breaks equals 50. So this is now going to be 50 boxes of my histogram. You can see that here. I have 50 different boxes now, and it automatically scales the boxes to sort of cover the whole range of the data. Here I've got another one. This is for the non-COVID patients. So it's much more filled because, right, you have more patients here that did not have COVID. Similarly, right, I can do this by history of C-section. Okay, so now I'm changing up here. I was looking at mean of term delivery, probability of having term delivery based on COVID history. And here I was looking at the probability of term delivery based on non-COVID history. I can do this for C-sections instead. So all I'm doing is replacing this COVID history with history of C-section. So it's here. So 54% of patients with a history of C-section had a term delivery compared to about 60% that didn't. Are those drastically different? I don't know. We're not talking about statistical tests yet. And I can change this code to look at other things, right? So I can come down here. I think I had another variable, type O. I can go $, see this. Now I have $. I can say, oh, type O blood. Type O blood, 55%. I can also change it to 0. This would now be 58%. So type O blood definitely doesn't seem to have a big difference here. I can look at different past functions over these as well. So histogram is just a function as well. I can get the variance of this. So this is the variance of the BMI patients without a COVID history. It's 51. And the variance of the patients with a COVID history, it's 54. I can do the means too, right? So I can come up here and just change these to mean, 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 like that. 32, 32. So this is something you also might want to do, plot a scatter plot. So I have age, right? Data age, and I have data BMI. Maybe I want to know, does age and BMI, are they correlated? So I can do a scatter plot. And if you want to look at the plot command, there's actually a lot of sort of default things you can do. But the main syntax is you pass an X in here and you pass a Y value. So here I'm saying, hey, look, I want age on the X axis and I want BMI on the Y axis. My title is going to be a scatter plot of age by BMI. My X label is going to be age. My Y label is going to be BMI. And remember in a couple lectures ago, we talked about type here. So type here is P would be for points, L would be for lines, O would be for points and lines, and H would be for vertical bars. So let's run this code and see what we got. So this is our scatter plot. It is really busy, right? So we have lots of data, and you can see, right, why does it look like this? Why is it separated? Because age is recorded as a discrete variable. So if somebody's 25, somebody's 26, somebody's 27, somebody's 28. They're not 25.87, at least in this data set. Now in real life, right, you could totally record the data set that way to be more continuous. But BMI here is continuous. Okay, let's see. So I can do the same thing, subsetting by COVID history. So all I've changed here between this line of code and this line of code is I'm now subsetting age by COVID history equals 1, which means I also have to subset BMI by COVID history equals 1. So I run this. This is what that looks like, the scatter plot. Now let me show you what would happen if I mistakenly had a 0 here and a 1 there. Okay, so here, this is the ages of people without COVID. This is the BMIs of people with COVID. I get an error, and this error says that, hey, look, the links differ. And so what I can do is I can actually check this, right? So maybe I want to debug this. I can pass this in the bottom, and the up arrow on your keyboard can actually pull the last code that you just ran up. If I do that, I can come here and I can type in length. Okay, the length of this is 893. Okay, now I can look at the length of this one here. So I run this, and again, I'll just pass it back up, press up again, and I can say length. The length of this one is 107. So I know that those lengths are wrong, and then I can kind of figure out what the issue is. So this is my plot. This is by COVID. See, I added that title here. I can do the same thing. I can add the points here of the non-COVID cases. So you see here, I've got 0 and zeros. PCH here is basically a command to give you different plotting symbols. And you can play around with this. And color, obviously, is to change the color. So I can look at this. You can see, hey, look, I laid over this different symbol for the non-COVID cases. You can't really discriminate them too well, but you know, that's something you could try. So I can try maybe 2. What does 2 look like? I actually need to rerun the plot if I want to add new things. So this is 2, right? It's triangles. If you look into R, you know, go to R PCH. You can actually see there's some images, what these look like. So these will just change the plotting symbols here. Okay, what if I want to know what proportion of mothers have a BMI over 30 in each of these groups? Well, the first thing I might do is I might just say BMI over 30, over 30. This turns it into a logical statement. This is the indicator, right? Just like we were looking at. So what I'm computing is, you know, I'm computing P, BMI over 30. So I can do that here. I can say, see my console on the bottom. I just take the mean of that. The mean of that is 0.593. Now all I'm doing is just adding a subset here. So if I add the subset, I have 67% in the COVID positive group, and I have 58% in the COVID positive group. Likewise, I can pass quantiles onto the subset. So I can use the quantile function. I can use prob equals 0.251 to get the 0.25 quantile. I can pass it through here. The 0.25 quantile here is 25.44 for the COVID history positive group, and is 26.46 for the non-COVID history positive group. So another way to do all this is using the subset command. So the subset command here, basically you have to you subset the data based on some condition. So what I'm saying here is I'm creating a new data set called data COVID. So it's setting equal to the subset of data, and it's saying all the places where COVID history equals 1. So I can do that. And I can also do the same thing for data no COVID. Now I can actually look at the data, do the head of this is data COVID, and I can see I literally have the same data set. I have exactly the same data set. It's just a smaller data set. It's all the COVID history equals 1. And I should actually be able to print out the whole thing, data COVID. So here I have my data COVID, and here you see how it has skipping lines. These are the numbers that had that condition satisfied. So I can see all my data here. I can plot these, right? So this is in my data COVID. I'm plotting age and BMI. This is my scatter plot. I don't have the titles here, so I might make the titles better. I could say, hey, look, you know, Y lab equals BMI, X lab equals age. That'll replace these. If I want to add a main title, I can say main equals main title. Okay. And then I can do the same thing in the non-COVID data set. So data no COVID is my non-COVID data set. And then I can get quantiles in each of these. So maybe I want, what's the quantile, the median of age? So I'm saying, hey, look, remember quantile function, I supply a vector, and then I supply my, which quantile I want. Hey, R, I want the 0.5 quantile. Okay, there it is, it's 22 of age in the COVID group. Now I'm saying, hey, look, in the no COVID group, what do I want? I want the 0.5 quantile, that's also 22. I also might plot histograms of these. So here's the histogram of COVID age. And I can clean up these axes again, right? If I press up in the bottom, I can say, you know, X lab equals age, Y lab equals BMI, and main equals BMI age by BMI or whatever. So you can see here, it actually repopulated it. And I can do the same thing in the no COVID group. So that's it for today. I also want to point out a resource. So DataCamp. DataCamp, I think, is a very nice resource for kind of getting into this. You could do the free course, the Introduction to R. I think that is helpful, at least getting into it. It's extra material. There's lots of these kind of things on here. So let's look at the homework and what I'm looking for here. So if you go to the homework, and I'll upload this file later, you go to Bsph 3302. Go to the homework, module 1 assignment. So module 1 assignment, what I want you to do is download this data set. So you should answer all the questions in a Word document with all the question numbers clearly labeled. When you use R to present graphs, put the code and the output. So, you know, you'll say something like, hey, code, and you'll have blah, 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 blah. And then you'll have output, and then you'll have a graph or summary, whatever it is. So you can just paste it from your R, that's fine. And then you can comment on results for each question. So that's what I'm looking for. This is the data set here. It's heart disease.csv. It's data collected at a primary visit for 100 patients without heart disease who are under 50 years old. So the variables here are race, the race of the patient, whether they're Asian, they're Black, or they're white, age, which is the age of the patient, BMI, which is their body mass index, the sodium level, which is their recorded sodium level at the patient visit, and then 5 years heart disease status. So whether or not they got heart disease in 5 years. And if I download the file, you can see that here, right? So this first patient, just to read, how do you read it? This first patient was white. This first patient was 31. This first patient had a BMI of 30.61. This first patient had a sodium level of 139. And this first patient did not get heart disease within 5 years after this visit. So what I'm looking for are the following questions. The first thing is, assuming that the heart rates of the rates of heart disease are the same for each patient, follows a binomial distribution. The rate of heart disease is estimated at 48%. How many heart disease patients are in this data set? And what's the probability of observing this number of heart diseases out of 100 patients, assuming a real rate of 48%. So what I'm looking for here is using the d-binom function, based on what you're actually going to plug in is you're going to plug in what is the actual number of heart disease in the data set. You'll plug in your sample size, and you'll plug in the hypothesized heart disease rate. So you have to figure out what this is from your data set, how many heart diseases there are, which you can use sum for that. Second question is calculate the mean and the standard deviation of the BMI in each racial group. So you'll look at what's the mean and BMI, standard deviation of BMI in Caucasians, African Americans, and Asian Americans. And what's the probability of each average, assuming that BMI follows a normal distribution with mean 27 and standard deviation 7. So you'll have each mean there, and you'll plug it into the d-norm function. So these are related to the second lecture. Okay, so you'll, in similar to this sort of approach here, you'll put the actual there. You'll do the same kind of thing with d-norm with the actual means. And I think I have what down here, I have 27 and 7, 27, 27, 7. And you'll tell me what those values are. The third question is just a simulation-based question. So you're going to generate 10 normal random variables from a 27-7 distribution. So you're going to use our norm here, and you're going to show my result. You show the result. So you'll print out, you'll save a vector as like X, and you'll just show me what X looks like. Then you'll tell me what's the value of this function. Now remember, this is the value, it's a sum of the indicator of X squared plus 2 times X being bigger than 10. So for your generated data set, what is the value of this function passing through these indicators? Some other questions. What proportion of patients in the whole data set have a BMI between 30 and 35? So for that, remember, right, we have this command, we have this and command, and get that. Right, so you could say, you know, an indicator statement, you could say, I don't want to give away the answer, but, you know, for example, you might look at what proportion or how many patients are Asians and have a BMI over 30. So you might say, you know, BMI over 30 and race equals Asian. So I think I don't know if I mentioned this, but you know, you could see it in the code. When you want to get a logical statement on equals, you can see here I have equal. You have to use equals here. So double equals together. What proportion of patient in each heart disease group have an age below 30? So given that they developed heart disease or didn't, what proportion in those groups had an age below 30? Next, I'd like you to plot a histogram of the sodium levels in each heart disease group. So for those that had heart disease and those that didn't, and you want to label this plot and comment on the differences. So, you know, are the people that have heart disease, or they generally have higher sodium levels or lower? You'll plot a scatter plot of the BMI and the sodium levels in each heart disease group, and you'll label the plot. And then I also want you to use one plot and color the heart disease patients red. So that looks like this example here. It doesn't matter what symbol you use, but you'll want to color them different colors. The next question is, and the last question is, what proportion of patients with the sodium levels above 40 developed heart disease? And so this should be age, actually. What percentage of patients with age above 40 developed heart disease, and what proportion of age below 40 developed heart disease? And that's the end. So please let me know if you have any questions. I have office hours to answer all of these. I encourage you, if you're having trouble getting started into R using DataCamp, just to kind of get familiar. Also reading through the lectures again, walking through the code that we have. I think that will really help you. The first thing I would do is just read the data set into R. All right, I hope you have a good week. And if you have any questions, please feel free to ask.